Hi everyone. Well, congratulations on finishing astronomy through distance learning. First time I've ever taught a course over distance learning, and the first time I'm guessing that a lot of you have learned, unless you've taken some sort of online course before. We're going to jump back into chemistry. It's really important that we finish this chemistry unit up. It'll definitely be the basis of knowledge you need for grade 10 chemistry. I was hoping that we could save this till we get back to school. I want you to be able to do the labs. Labs are definitely the fun part. Unfortunately, I'm not sure if we're going to make it back. So in order to make sure that you have this information, we're going to jump back into this one and save electricity till the end. All right. We had already been 3 or 4 lessons in, I believe. I can't remember exactly where we left off, but what I want to do in this video is just go back over what we've done already, give you the talking points of it so it all comes back to memory. I'll also give you these lessons again. For a lot of you, I'm assuming that these lessons, these notes are in your locker, but if not, you'll have a new copy. So we started off with particle theory and matter. And first of all, matter is anything that has mass or weight and takes up space. I told you before, on the tip of a needle, the pointing of a needle, there are billions of atoms. That's how small an atom is. And everything is made up of these atoms. And so what chemistry is and particle theory is describing what these atoms are made up of and how they behave. Now, 5 main ideas of particle theory, and that is all matter is made up of tiny particles and is separated by empty space in between them. And that empty space is not air, it's not something else, it's literally a void. There's nothing there. In fact, the air in your room right now, that's tiny particles, tiny oxygen particles, tiny carbon dioxide particles. And in between those particles, there's nothing. So in between the air molecules, there's literally nothing there. Different substances are made up of different types of particles. Gold is made up of gold particles or atoms. And we'll learn later that they look and act differently than a rubidium particle or a carbon particle or a neon particle. So all these different particles or different things are made up of different particle types. Particles attract each other. They do have a gravity, very, very small, but they do attract each other. Particles are constantly moving. They zigzag, they vibrate, and the more that you warm them up, the faster they move. If you cool them down, they slow down. And so here's a graphical representation of particles in the 3 different states of matter. Solids. When the particles, if we use the example of water particles here, this could be an ice cube. And first of all, in solid form, all the water particles here, they have, because it's, in this case, colder, the particles have slowed down and they have actually arranged themselves in these neat arrays, these rows and columns. The solid is very dense, and solid holds its shape. So think of an ice cube. You put an ice cube into a cup, you can still see the ice cube. So it's holding its shape. In liquid form, the molecules are still very densely packed together. In this case, if this was water, they're moving a little bit faster because they are warmer. They take the shape of the container. So we can see here that these molecules are filling the shape of the container. If I also pour this into a different shaped container, the shape of that water would change. And last but not least, we have gas. You can see in this case that the molecules are moving the fastest. They also take the shape of the container, so it totally fills this container. If I also put it into a bigger container, the gas molecules would spread out further and occupy the whole container as well. We discussed the movement between these three. Some of this we knew already. So liquid, it can evaporate into a gas, or if it's in gas form, it can condense back into liquid form. From gas to solid, and from solid to gas, we are talking sublimation. A good example of when this happens, dry ice is solid form, and it will go straight into gas form when it warms up. It won't turn into liquid first. And from liquid to solid, we have freezing or solidification. Solidification, a good example there is candle wax. You don't need to freeze it to make it turn into a solid, but when it cools down, it will solidify back into a solid. And from solid to liquid, we have melting or liquefaction. Once again, actually, I won't go to that example. Then we got into pure substances and mixtures. So pure substance is when we only have one particle type. In a beaker, if we have just H2O particles, then it's a pure substance. If in a bracelet, if we just have 100% gold particles, then it is a pure substance. In a room, if you have just oxygen and nothing else, then that is a pure substance. Now, gold is made up of one thing and one thing only, gold particles, or gold atoms. Water is made up of two things, so hydrogen and oxygen. And when that hydrogen and oxygen bonds together, we get water. However, if in a container you have just water particles, then it is pure. Now, finding pure substances is often very tough. When you turn on the tap, that is not pure water. What's coming out of that tap is not only water particles, but there's some salt in there, there's some chlorine in there, there's trace or minute amounts of different metals. Likewise, in your room right now, you are not breathing pure oxygen. Only 21% of the particles floating around you right now are oxygen. 78 of them percent are nitrogen, and 1% other things, including carbon dioxide. Even in a gold bracelet, quite often gold is very soft. Quite often other metals are mixed in to make it a little bit hard, a little bit more dent and scratch resistant, and so it doesn't break. Now when we mix other things in, it becomes a mixture. So that water coming out of your tap is a mixture. The gold on your bracelet, if there's other metals mixed in, it's a mixture. The air in your room is not just oxygen. It has carbon dioxide, argon, nitrogen, so it's a mixture. So a mixture is a substance that contains more than one type of particle. In air, we can't see the different, I can't look up right now and see nitrogen and oxygen. It just all looks the same. In a granola bar, I can definitely see that mixture. I can see the granola, I can see the raisins, the nuts, the chocolate, whatever it might be that's in there. So that comes to brings us to two different types of mixtures. So first is heterogeneous mixture, otherwise sometimes referred to as a mechanical mixture. And this is where you can see the different types of particles using the naked eye or even through a microscope. So in my cereal, I can see the milk, I can see the raisins, I can see the bran, salad dressing, I can see the oil, the water, the vinegar, the different herbs and spices that are in there. I can see all the different parts. So it's a heterogeneous mixture. A homogeneous mixture is where I can't see the different parts. When I look at a glass of salt water, I can't see the salt. When I look at brass, which is an alloy, it's a mixture of metals, it all looks the same to me. I can't see the different parts of it. Likewise with apple juice, I can't see the apple, I can't see the water, I can't see the vitamin C that's in there. It's got a mixture of a lot of different things. I can't see them all. It only appears to be one thing. And so that's a homogeneous mixture or a solution. Now, if a liquid is cloudy or opaque, opaque meaning we can't see through it, it will be a mechanical mixture. So milk, even though it looks like just one thing, this white substance, it is a mechanical mixture. And of course, milk has water in it, it has fat in it, it has calcium in it, it has different vitamins in it. So it's definitely a mixture of different things. It's not just one substance. And an alloy. When we mix metals together, we call that an alloy. And so stainless steel which is what your utensils are made up of. Brass, bronze. These are alloys where we've mixed metals together so we get different properties. I think I talked in class about how every time you wash your fork, you don't want it to rust. So a mixture of metals has been blended together to form stainless steel. Stainless steel is rust resistant. Likewise, brass, which is a mixture of copper and zinc, it is it's rust resistant as well. So quite often you'll find brass on boats, and it's resistant to rust and corrosion from salt as well. So definitely on boats that are going into salt water, we'll utilize brass rather than other types of metals. So we have this full chart. You did have copies of that. If not, the notes that I'm sending you, you will now have new copies. We started to get into physical properties and changes. So a physical property is a characteristic of a substance that can't be observed or measured without changing the identity. So if I look at a piece of wood, I can talk about the physical properties of it. It's hard. It's a solid. It's brown. It's not very hard. It's opaque. I can't see through it. Light doesn't go through it. So I can observe these things or measure them without actually having to change it. If we're getting into changing what it is, then it becomes a chemical property. And we'll discuss that a little bit later. Now, two different types of physical properties, qualitative and quantitative. Qualitative is not measured. Quantitative, and I realize that there is a typo here. It should be quantitative, and that is that means that it can be measured. So if I say a piece of wood is brown, or that hamburger smells, or that salt is bitter, those are all qualitative. There's no numbers involved. As soon as there's numbers involved, it becomes quantitative. So if I say that piece of wood is 12 centimeters long, that water has an acidity level of 6.4, that ice cube will melt at 0 degrees Celsius. As soon as we have included a number, then it becomes a quantitative. And we strive as chemists to try to use both of these properties. They're both very valid. So vinegar is colorless. It's a liquid. It has a sharp odor, a sour taste. Those are all qualitative. It has a boiling point of 101 degrees Celsius, quantitative. And so other physical properties that we describe matter by the clarity. So transparent. So if we're thinking of glass, or a liquid. Transparent is you can see through it like a window. Translucent is like your bathroom window where it's letting light through but you can't quite see through it. And opaque is like a piece of wood. It's not letting light through, you can't see through it. Luster. Quite often we use luster for metals, but it doesn't necessarily have to be just for metals. But can it reflect light? So is it shiny? Is it dull? The texture. This could be on a solid. Especially too when we're dealing with things like sand or salt. Is it fine, like the salt that you put on your french fries? Is it coarse, like the rough salt that we throw on our driveway to melt the ice? Is it smooth? Hardness. So what's its resistant to being scratched or dented? Brittleness. Will it break apart? Glass is brittle. You drop it, it'll break. A piece of copper is not brittle. It will not break. The next two, malleability and ductility, these are usually for metal. Can you hammer malleability? Can you flatten it into sheets? And I don't necessarily mean yourself, but with a machine, can you flatten out a big ball of copper? And the answer is yes. Ductility, can you pull it out into wires? Yes. Viscosity is resistance to flow. Water flows easily. Maple syrup does not. Conductivity, usually for metals again. Will heat and electricity be conducted through it? Solubility, can you dissolve it? And density, how close are those atoms to each other? All right, I noticed that I'm coming up to the 15-minute mark, and that's all I can do. So I will pause here and create a new video for the rest.